All right, our second objective is to interpret the standard deviation. So we first need to talk about what the standard deviation is, and it's the typical distance values are from the mean. So how far away once we find the mean, and standard deviation is dealing with the mean. Now, standard deviation, we are going to deal with this quite a bit. Okay, so we're going to call this and abbreviate STD. I know that stands for something else, but in stats class, that stands for standard deviation. Okay, so it's the typical distance values are from the mean. Okay, and then we have this long, ugly formula. If the data set contains x1, x2, all the way to xn, we can use this formula where we take x1 and subtract. Do we remember what X bar stands for? X bar is the mean. So we would take each value, subtract the mean, square it, and then add it. It's a lot of math. We don't have to do that. We have the stats applet. So there's no need to, I mean, you can write this formula down and you'll see this formula, but the stats applet will do all of the math for us. We're just more worried about being able to analyze it, okay? And then this is another really important abbreviation as we move forward in this class. S sub x just stands for the sample standard deviation. Okay, so it's just the sample standard deviation there. So again, the formulas are there. If you want to write them down and have them in your notes, you're more than welcome to. But we're going to do most of this stuff using the applet. So don't necessarily need to have that memorized, but it's there. And if you ever need it, it's available to you. Okay, so we are going to now look at some definitions. Okay, so properties of standard deviation. When we look at standard deviation, we've got to understand that it's the distance, right? So the distance is always greater than or equal to 0. So it's the distance that a value is from the mean. Okay, the larger values indicate greater variation. So the larger that our standard deviation is means that the wider, more spread out that the data is. Okay, it's not resistance. Okay, again, we're dealing with the mean, and if we change those outliers, it definitely changes the mean. So this is not resistance. Okay, and again, it just measures the variation about the mean. So once we find the mean, it's how far away these values are from the mean of the given data. So again, those are 4 things to note and to look at. So the next thing that we're going to look at is, how do we choose the measures of center and variability? So when do I want to use IQR? When do I want to use the standard deviation? And if it's skewed or with outliers, we want to use the median and IQR. If there's data that's way out there, okay, or resistant, then we want to use the median and the IQR. And again, sometimes we do this with grades. If one student really does well on a test and the rest of us get a 70% or a 75%, then we're going to kind of exclude that one test that got 100 so the rest of us can get the higher grade when it's curved. Okay, if it's roughly symmetric with no outliers, then this is when we want to use the mean and the standard deviation. Okay, so we'd want to use the mean and standard deviation. Okay, as we go through this. So if you got roughly symmetric data, that's when we would go about and use the standard deviation. So let's take a look at an example here. Okay, it says the 9 children were asked how many pets they had. The dot plot shows their responses. So here you can see a student had 1 pet, 3 pets, 4 pets, 3 different times, and 5 pets, 7 pet, 8 pet, 9 pet. So we want to calculate the standard deviation. Again, you could take this and you could find the mean, and then you could plug this into the formula and do all of that work, which would be a little bit time consuming, or we can go to the stats applet and we can enter the data there. So this is one quantitative variable. Okay, and again, if I needed to, I could enter in the variable name if we wanted to look at the stat plot, but I don't really care so much about that. So I'm just going to enter in 1, enter all the values, right? 1, 2, no, 3, 4, 3 times, 5, 7, 8, and 9. I would never want 9 pets. Okay, so begin analysis, and we have it right here from this table. Again, you could copy that down to write that down. I'm going to go ahead and just take a picture of it and put it over there so we can see it. So here's all the information that we need. Come on now. Maybe it's not going to let me do it. No, it's not. Yeah, there it is. Okay. So here's all the information. 9 sets of data there. So there should be 9 dots, and there is. So the first thing that we're going to write down is, well, what's the mean? Okay. Notice how I'm labeling the mean. Okay. I'm putting X bar is equal to 5. Well, what does that mean? 5 pets. Okay. And the standard deviation, S sub X, is 2.55 pets. So right here is approximately my mean. Okay. And that means that any one of these dots is about 2.55 from the mean. Now, as we look at this and we look at the right side of this standard deviation, we see that this is 2 values away. Okay. From here to here is 3 values away. And from here to here is 4 values away. Okay. And this isn't always going to happen, but here is 1, 1, 1. From here to here is 2, and from here to here is 4. If we add all these up, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, it comes out to be somewhat symmetric or even when we look at those values. Okay. Now, it doesn't necessarily mean it has the same number on each side, as this has 5 and this has 3. But as we look at that, so there's the standard deviation, again, done through the stats applet. Should not be very difficult mathematically because we're just entering that stuff in there and then it's telling us. Now, here's what is important is how we interpret it. Okay. So how do we interpret it? What am I looking for? You're going to use the sentence, the number of pets, okay, typically varies. So we will use this word right here, typically varies. And then we put in the standard deviation, which would be pi by 2.55. And you can write the word pets there, like if this was in inches or centimeters, then we would put the label there. But I already did. The number of pets typically varies by 2.55 from the mean of 5. Okay, so again, when I ask you to interpret the value in context, this is the sentence that I'm looking for. You're going to use typically varies by, and this right here is my standard deviation. And you're going to say from the mean of, and this right here is my mean. So as we go through, and we will do this quite a bit throughout this class, is where I'm asking you to find the standard deviation and interpret it. So you're going to use this sentence quite a bit. Okay, so make sure that you have this written down. And again, we're just going to fill in the blanks. What are we talking about? That goes here. We're always going to use typically varies by, and we're going to put the standard deviation, and then we're going to say from the mean, whatever the mean is. Okay.